In this chapter, we're going to start building the control rig. We're going to base it off of our deformation skeleton to a large extent. So to do that, we're going to actually not rig our character in this this pose with the arms at 45s. Instead, we're going to create a rig with the arms in a T pose. So before we get going on creating this control rig, I want to talk about bind poses and what I'm going to call a rig pose. The bind pose in Maya has typically been something that hasn't really been too useful, and that's mostly to do with the fact that Maya doesn't provide a very clean interface to how it needs to be used. Basically, it doesn't like to have any joints that are part of it have any connections going into them or be locked, have their channels locked. So if you've rigged a character and you've skinned it, but and you have some of the joints connected into a control rig with constraints, or you've put keys on it, basically the skin go to bind pose command is going to fail, and you're not going to be able to return your skin to its bind pose. Now, not only that, there is a little bit of a bug. I looked through the scripts, how it goes about finding the bind pose, and that actually has varied in this new version of 2011 from 2009. So it's just never really been implemented very well. So you'd have to be real careful how it was used, and oftentimes, myself included, would just delete them, be like, it's more trouble than it's worth dealing with that bind pose node. But we're going to maintain a clear distinction between our deformation skeleton and our control rig. So by doing that, we're going to basically build ourselves a little workflow and interface to using these pose nodes, and that way we can easily detach our control rig, or our deformation skeleton from our control rig, go back to bind pose easily, apply a rig pose easily. So we can easily go back to swap out new meshes, or put our skeleton into some other position to accept some other mesh, and that mesh can have its own bind pose, and we can move the skeleton back and forth between various bind pose states for various mesh pieces, as well as go back to our rig pose. So anyway, first step here is going to be to throw a basic skin on our character so that we can move our joints into our rig pose. And this is also the step we're going to take here that allows us to identify any problems. So we're not going to take our skinning to a super polished state, or even really a polished state, but we want to get it rough enough or good enough that we know that it's our joint placement sound, because after this step our control rig will be created off of it, and you'll just have to tear it all apart if you end up not really liking these joint positions. So best to like what you've done up to this point before you move on. So to do that, I'm not going to really cover skinning too much here. Carlos Antonetti does a nice job in his DVD. So he's got two of them. He's got a puppet rig one and the skin character rig. So if you want more of a introduction to the skinning tools and some of the settings and like the joint tool and stuff, I definitely recommend checking out his DVDs. So when I skin something, I don't want to skin any other joint into it that I don't need skin to that mesh piece. In this case, our character's pretty much just one solid mesh. I mean, she has some various accessories, and these heels arguably could have been put into this mesh as well, but they make sense that they're not, so whatever. So in this case, it'll be pretty much all these joints, but let's say the body was split at the waist, or if it was a different character, I wouldn't want to be selecting these lower leg joints and ankle joints and have those joints influence my upper torso geometry. When you're painting weights, if you have other influences involved in your skin cluster for that geometry, it's just one more place I can jump a weight value off and mess you up. So, and it adds more overhead. It's not clean. So in this case, we're not going to be skinning to this body joint. This body joint's really our character's sort of root. So we'll be skinning to the pelvis, and we don't skin to these end joints like left, excuse me, left ball end or right ball end, or that chest end joint for that matter. So I select all these joints, then select the mesh, and then I'm going to go skin, bind skin, smooth bind, go to the option box. Let's see what we got here. I'm going to reset these settings just so you can see what they are by default. So this bind to joint hierarchy, we want to change that to selected joints. That's first thing you should do before you skin anything, really. That way you're very specific about what you're binding to. You're not just saying, here's a joint and some hierarchy I made, now skin this sucker to everything. And that's what the hierarchy option will do. It'll grab all these end joints. It's just not necessary, not clean. Closest in hierarchy is fine. Skinning method, we're going to just use the linear for now. There's new options in 2011, this dual quaternion that maintains volume a lot better. It basically adds rotation really into the mix of where that point ends up lying. And this normalized weights option too, which is a new way to allow you to paint weights on your model without your values jumping and popping to other joints. Basically, your weight values won't be going from 0 to 1. They'll now be it'll be sort of like a ratio of the two, and then after that you'll normalize them back to 1 and get some percentage of each. Basically, the relationship of the two compared to each other will then be brought into a 0 to 1 scale. Max influences, this is a little high. Well, I mean, for game engine, we're going to set this to 4. For character 6, 4 is a good start, but you may start bumping this up in areas where you need a little bit more, but I'd start with 4. Drop off rate around 4 is fine. Maintaining max influences, if this is a game character where you likely have 4 influences that you're allowed to use due to memory reasons, maintaining max influences is a good idea, and it can be a good idea anyways. And I will try not to start going over 4 influences per vert, but it happens. Skin clusters get a little screwy sometimes. And colorized skeleton's fine. I uncheck this remove unused influences. If there's a joint that didn't get any skinning information, it'll be dropped out of the skin cluster, and that's not what I want. I want to be as explicit as possible, so selected joints and uncheck remove unused influences. And we're going to bind this. So with our mesh bound, I'm going to load up the Comet menu and load up the Comet Save Weights tool. Carlos Ansonetti does a nice job of explaining how this tool works, as well as a lot of the other tools in here that Mike Comet's written. So I recommend checking it out for that, as well as some of the other stuff he brings up in there. So we'll load up this file here in our projects directory. I put it in the data folder. Body weights, my ASCII file. It's just a text file. It's going to say save here, and it's going to say, do you want to replace it? Just say yes. It's really just loading it into this tool. Until you say save weights on this file, it's not going to actually rewrite the text file in there. So don't be scared about saying, do you want to replace it? And now that it's loaded up here, we can do select joints from file. And it'll select all the joints that it finds in that file, of course. And you can see none of those end joints have been selected. And we'll select our mesh. I guess it wasn't bound skinned. Smooth bind. And select all the verts. Hit this arrow to load up this associated skin cluster, and you hit the load weights button. Now this can take a little while with dense meshes, so just be patient. It is working, unless it errors out immediately on you. And it should be noted that I've actually provided on the disk this script. There was a little bit of a bug in it that was causing it to not work quite properly. So I made a very small change to the file, comet save weights.mil. It's not the entire package of Comet scripts. There's many other other files associated with these tools. It's just one piece of the pie there, but you'll want to grab that file off the disk for my 2011, at least for the time being. If you're getting errors and it's just not working and you're following the proper steps, it's likely you're running across the same little bug I did. So you can grab that updated file off the disk. So with our weights loaded here, I want to talk a little bit more about this idea of a bind pose and a rig pose. When you skin something, if we go to the hypergraph view here and the input-output connections, and look at the skin cluster. The skin cluster by default has a where is it? Bind pose node associated with it. So if we graph the input-output connections off of our skin cluster, we're going to see this bind pose node. If we type in this mel command here, node type, listing selection, result is that it's a DAG pose node, and the DAG pose being our hierarchical nodes with translate, rotate, scale transforms and joints. So that's really all a bind pose node is this. You can see every joint feeding into it. It's the storage of that joint's transformations, not only in the channel box values, but in joint orients, segment scale compensate, some other attributes, the states, whether they're frozen or not, pivot points, also, all sorts of stuff. And they're actually really useful little nodes, but they whine a lot if any of these joints have properties that prevent it from setting its values. But if we confine this node to just our deformation skeleton, it works pretty well, and we can build a workflow and some tools around it. It makes it real simple to work with it, and actually is pretty nice. So I mentioned a rig pose node. This rig pose is exactly this same node. I'm just sort of using that as that'll be our way to store a pose that is what we want to start from for our rig here. So I'm going to put this model into a T-pose. I'm going to close this window. And I'm just going to use this T-pose. T-pose is sort of picked, I think probably initially got picked because you sort of line your arms up with the axes of the world a bit. Sort of halfway between a raised arm point. There's probably multiple reasons, more reasons. Regardless, it's become an industry standard. Packages like Motion Builder, Mocap Studios. A lot of places tend to use that T-pose as their starting point of motion data. So it makes sense to sort of start from there. And your controllers will line up with the world values, so it's a little bit more intuitive. But as you can see, we didn't skin our character in that pose, so I definitely don't want to, I think modeling in a T-pose has become something that's sort of the past. Raising your arms is actually a somewhat, I wouldn't say extreme motion, but leads to a lot of changes in the underlying shape of a character. Drawings, concept art isn't typically done like that unless it's being done specifically as a orthographic view, but for the model. But you can get nicer deformations by binding in poses that are different from T-pose. But we're going to create a rig and start our motion from there. And since we bound at a different pose, when our character gets closer into these natural positions, our deformations are going to look better. So to do that, open up the attribute editor, and we're going to basically set these values such that we flatten out raise the arms up. And this clavicle is tilted down a little bit here. That's our twist. We're going to want to raise this straight and level out the arm here. So let me see, what do we got? Negative 90. No, let's. So this joint, we're actually running into a little bit of a issue. So for this, I'm actually going to use the rotate axis, so when adjusting this stuff, you can run into, if you're just using the joint orient fields by hand, you can run into a bit of screwiness where basically you've rotated in such a way that you're not really matching up with the right rotation orders anymore. So in that case, just use your rotation channels in your channel box to set this stuff. So these clavicles, your clavicles really don't move that much forward or back, but these arms are pressed a little bit back here. So we're going to straighten them out a little bit. Bringing the arms forward a touch. And bringing the clavicles up. And since the clavicle's joint position relative was lower than the clavicle initially, when we raise it to draw horizontal in this view, it's really describing elevated clavicle here. And for the arms, we can also, using the joint orient field here, you can be a lot more precise than sort of countering with the rotations in the channel box. So when it makes sense to do so, use the joint orient fields like here. I'm going to pull this to a true 90, and this, I believe, 0. Now we've really lined that arm up to be flat, coming up off the clavicle joint. It's oriented slightly differently, but it's flat to it. Now we just want to do the same to the other side here. Bringing the arms out. Then we're going to make a few other small adjustments here. Bring the hands into a spot. And you're going to want to keep your hands oriented to the world axes, both from the top view and your side view, and level them out. Now it looks like here I actually have a very poorly poorly oriented hand joint. So this is something that actually needs to be fixed. So for that, here I'm going to have to save off my weights and make that fix and reapply my weighting. But I'm going to show this principle here of storing a rig pose. So the rig pose here, we've got the arms elevated, much like, well, not really much like, the bind pose is created when you skin something. To store a rig pose, if you have this shelf loaded up, as shown in the first chapter, there's this RP button here, rig pose. If you select your mesh and click on this button, it's going to store a rig pose for your character. If you click it again and it detects a rig pose, it's going to ask you if you want to make a new one, so you're not accidentally creating new rig poses for your character. Once you do this, it's just a simple matter of having your mesh selected, and you can use these buttons right next to it, 2RP and 2BP, 2 bind pose, to pop your character back and forth between its rig pose and bind pose. And since we're going to build our control rig off of this rig pose here, it's yet we're not done skinning. I have an easy place to pop back to, add some additional influences like twist joints, etc., either now or down the line as my deformation skeleton evolves. So for this, I'm going to put it back to bind pose and save off my weights. I won't bother you with that process again, and do the magic of editing. They'll be reapplied here in a second. But you know what, actually I'm going to step through the process of properly orienting this hand joint. So I'm going to detach the skinning, clear it all out. And I spoke earlier in the last chapter about using reference objects when orienting your joints. These hands are a great example of that. Hands and oftentimes feet are modeled in the local space that has quite a bit of rotation on it. So to do that, I'm just going to create a simple polycube, select this wrist joint, parent the cube in. Now since I haven't frozen transforms yet, if I zero out the translates, it's going to pop it to the space of that joint. And boy, that joint is nasty. So with my wrist joint, I actually I like my joint orient to be 90 from its parent, to keep with the philosophy of the rotation Z channel being the main angle of rotation. Just a personal preference. And so if we take this cube and scale it to be a little bit more flat and indicative of a rectangle or a fake hand, we can get an actual visual on this stuff. Walk up to the joint here. It's far more level to the plane of the hand and what we want than it was before. I'm just going to delete that chain. You can obviously delete your dummy geometry once you're done using it, but that's a really nice way of aligning something with a visual. Otherwise, you're just looking at manipulators here, and you're going to be off more than you know. And we'll duplicate this chain back, or mirror this chain back over. And I'm going to import the weights real quick, and then we'll get back to building the rig here.